Have you ever been driving or hiking through a valley and just stopped and noticed something odd? How one side can be this lush, green, thriving place, and the other side, just a stone's throw away, looks totally different, almost barren? Well, today we're going to dig into the hidden world of valley climates, and we'll be using the incredible landscapes of South Africa to guide us. And that is the big question, right? How can two spots so incredibly close to each other be living in completely different worlds? This isn't just a curiosity. It's a question that has literally shaped where we build our homes, what we can grow, and the entire personality of a landscape. And of course, there isn't just one simple answer. It's this amazing story, this dance between three huge forces: the sun, the air, and the shape of the land itself. By the end of this, you'll be able to see this hidden story playing out in any landscape, understanding the invisible forces that decide where life really thrives. So, to get started, we need to get a handle on the most basic, fundamental difference between a valley's two faces. And it all boils down to one simple thing: which way is the slope facing? The magic word here is slope aspect. Now, it sounds kind of technical, but it's a really straightforward idea. It's just asking, which way is the hill pointing? But this one simple factor kicks off a massive chain reaction that creates two completely different little worlds. Okay, so let's follow the sun on its daily journey and see exactly how this works. We're going to focus on the southern hemisphere, since that's where our South African examples are. And here it is, side by side. It's pretty dramatic. In the southern hemisphere, the north-facing slopes are the ones that get blasted by the sun all day long. So what does that mean? Well, you get higher temperatures, the soil gets baked dry, and only certain plants can handle that heat. But then you look at the south-facing slopes, and they're cooler, they're shadier, they hold on to more water, and you get a completely different set of plants. It's literally two different worlds in one valley. But the sun's job isn't done. It doesn't just heat the ground, it gets the air moving. This daily cycle of heating and cooling creates these powerful local wind systems. It's almost like the valley itself is alive, like it's breathing. So here's how that breathing actually works. During the day, the sun warms up the slopes, which heats the air right above them. That air gets lighter, and it starts to rise up the sides of the valley. That's the valley exhaling. These are called anabatic winds. But then at night, everything flips. The slopes cool off fast, making the air next to them cold and heavy. So what does it do? It sinks, flowing down into the valley floor like a slow-motion river of cold air. That's the valley inhaling. And those are katabatic winds. And this idea, right, that the valley breathes, it's just the perfect way to think about it. This constant circulation, this daily rhythm of air rising and falling, well, it sets the stage for one of the most surprising, most counterintuitive things in all of weather science. And this brings us to the big secret, the hidden gem of valley climates. It's a fantastic twist where the normal rules of temperature get turned completely upside down. It's called a temperature inversion. Now, we all learn in school that the higher you go up a mountain, the colder it gets, right? Well, in a valley at night, that's often totally wrong. That cold, dense katabatic wind we just talked about, it pools at the bottom, and it actually traps a layer of warmer, lighter air on top of it. This whole process creates three distinct climate zones, all stacked vertically. At the very bottom, on the valley floor, you get what's called a frost pocket. It becomes the coldest part of the whole area. Way up at the top, the ridges are still cool and exposed to the wind, but in the middle, you get this amazing sweet spot, a thermal belt of warmer air literally sandwiched between the two cold layers. I mean, just let that sink in for a second. The most comfortable, the most frost-free, the warmest place in the entire valley is often halfway up the slope. It's this hidden layer of warmth that changes absolutely everything for the plants, animals, and people who live there. Oh, and there's a really beautiful side effect to all of this. When that cold air pulls at the bottom on a clear night, and there's just enough moisture in the air, you get something called radiation fog. It gets trapped by that warmer inversion layer sitting on top of it, which is what creates those absolutely stunning mornings where a thick sea of mist fills the valley and just the peaks are poking out into the sunshine. So this is all fascinating weather science, but it's not just theory. It has a direct, powerful impact on how we humans have lived in these landscapes for centuries. We've learned to adapt to these hidden rules. Just look at where people build their towns and their houses. For generations, people have instinctively known to avoid those cold, damp valley floors. Instead, you see settlements popping up right on those warmer, cozier thermal belts. And on the sunnier north-facing slopes, it's just a smart, practical decision that saves money on heating and makes life way more comfortable. And if you're a farmer, well, this knowledge is everything. It's your secret weapon. A winemaker will place a vineyard with surgical precision, maybe on a north-facing slope to get maximum sun for sweet grapes, but just high enough to be inside that thermal belt and avoid a devastating frost that could wipe out the whole crop. The entire economy of a wine region can literally depend on knowing exactly where these invisible climate lines are drawn. So, in the end, a valley isn't just a static piece of scenery to look at. It's a living, breathing system. It's this dynamic stage where the sun, the air, and the land are in a constant conversation, writing a really complex and beautiful story. And that kind of leaves us with one last thought. This stuff isn't just happening in the huge, dramatic valleys of South Africa. It's happening in the hills and dips of your own town, your own neighborhood. So the next time you're out for a walk, take a look around and ask yourself, what are the hidden geographies that are shaping the world right here, right where I live?
That was in my brain, if I said what's in my head. Should I let the record play? Do I play it to the end? Cause I've been here for days, going on repeat. I've been here for days, going on repeat, repeat.